Hey guys, Mr. Mackey here. Now yesterday we were going over algebra and I was showing you how to solve problems like this with a flowchart, and I set you the challenge of how we can reverse the process. I've done the first part of the flowchart, but now let's reverse it to find the original value, what x was. So let's do it. So if we have 31 and we're reversing it, instead of dividing by 6, we are timesing by 6. Now we do another arrow. Instead of timesing by 3, we're dividing by 3. Do another arrow. Instead of minusing 1, we are adding 1. Then instead of timesing by 7, we're dividing by 7 to get x. So let's do it. What's 31 times 6? Well, if you did your maths correctly, you would have gotten 186. What's 186 divided by 3? If you did your maths correctly on that bit as well, you would have gotten 62. What's 62 add 1? That will be 63. And what's 63 divided by 7? Well, 63 divided by 7 will get us 9. And that's our original value. That's what x is. How could we test it though? Well, you just put it back in the problem. 9 times 7 is 63, minus 1 62, times by 3 is 186, divided by 6 will get us 31. It works, it must be 9. Now yesterday we focused on the flowchart method, but there are more than one method of finding these sort of problems. I'm going to show you the other method today. The benefit of this method is you could use it to win much more challenging algebraic problems. And we're going to be focusing on not only the ones like this, but also some more challenging ones with the new method that I am going to teach you. And that method is called balancing. Now, balancing means that we have to change our algebraic expression, but we have to do it on both sides so we can balance the problem out. Let me show you with this one. So we have 5x plus 3 equals 48. Now what I want to do is I just want to balance this equation out so there's just x on this side and all the other numbers are on that side. So what would be the first thing to do? Well, we've got a plus 3 here, and I want to move that 3 to the other side of that equal sign. So how we're going to do that is we're going to minus 3, but on both sides, because we're balancing it. If we're balancing it, we're doing it both ways. So 5x plus 3 minus 3 will just get us 5x. And 48 minus 3 will get us 45. Do we continue? Well, yeah, because we haven't got an x, we have 5x. We need to get rid of that 5. So how do we get rid of that 5? Well, we divide it by 5 on both sides. So 5x divided by 5 will just end up with x, and 45 divided by 5 will get us 9. Do we do any more? No, because now we know what our x is. We have all our x on one side and we have all the others on the other side. So we can now say that x equals 9. And that's how we balance. Now many people are probably wondering right now, why do I need to know how to balance if you've given me a flowchart in the previous video? What's the point of me learning a new method if I'm so comfortable with the flowchart? Well, there's two answers to that. Firstly, it doesn't matter how many methods I give you. I want you to be comfortable with whichever method you like. So if you feel more comfortable using the flowchart to solve these problems, then use the flowchart. But if you feel more comfortable with the balancing approach I've just shown you, then use the balancing approach. But there is another reason why balancing is better than a flowchart, and I will show you in this problem. Now this is the problem we have. 3x plus 4 equals 2x plus 10. The problem with this is that what we're doing to the x is we're timesing it by 3 and then adding 4. But then the answer gets us another thing we're doing to the x. So the flowchart would not work for this because we're doing more than one thing to the x in two separate problems. They just won't work together. We can't actually reverse the process. So this is the circumstance where we have no choice but to balance it. So what we have to do is we have to put all our x's on one side and all our whole numbers, the numbers we know, on the other side. Now, how I like to do this first, the question that many of you are wondering is, which side do we put the x? Well, how I like to do it is I like to put it on the side where the x is actually bigger. Because if we're going to be minusing, which we will be in this, I want to actually end up with a positive number. Because negatives, they're a bit annoying. I've not even covered it yet. So if we've got a 3 here and a 2 here, I think the most sensible move is to minus 2x on both sides. Because that then moves the x to the side and it will guarantee us a positive number. So 3x plus 4 minus 2x will give us x plus 4. X is the same as 1x. It just means we don't have to write the 1, but that basically means 1x. 2x plus 10 minus 2x will just give us 10, because we've got rid of that 2x. Now, we need to get rid of that 4. So let's now move the 4 to the other side by balancing. So we're going to be minusing 4 on both sides. So x plus 4 minus 4 gets us, well, x, 1x. 10 minus 4 gets us 6. Do we need to do anything else? No. We've now balanced it out fully. We've now got all our x's on one side and all 6's on the other side, and we've simplified it to just end up with 1x, which is 6. Now this is one, now as I said, this we will have to balance. If you've balanced it out up to here, and then you'd rather use the flowchart from there, I'm not going to stop you. But wouldn't it be easier just to do balancing all in one go, like what I've done here, rather than focus on balancing and then have to remember another method? Flowcharts are useful for problems like this, where you have an x on one side and a whole number on the other, and you need to do it. But when you've got x's on both sides, it's even more tricky to use a flowchart. So in my opinion, I'd learn balancing very quickly, which is why I'm going to be doing a lot on this. Here's another example where we will have to be balancing, but this one might be a bit hard to follow and quite a few misconceptions might happen. So let's look. We have 2x minus 6 is the same as 5x plus 9. What's x? So what would we do first? Well, I'd like to move all my x's onto one side. The problem is we could move the 5 onto there, but then we'll end up with a negative value x. So what I might do is I might just move the 2 onto here, because we will end up then with a positive value of x. So what I'm going to do is I'm going to minus 2x on both sides. So when we do it, 2x minus 6 minus 2x will just give us negative 6. And then 5x plus 9 minus 2x will just give us 3x plus 9. Now let's move this 9 to the other side. How are we going to do that? We're going to be minusing 9 on both sides. So what is negative 6 minus 9? That will get us negative 15. And what's 3x plus 9 minus 9? That will just be 3x. Now many of you are probably a bit annoyed right now because the x is not on the side you'd want to do how we usually do it. But here's a little trick. Negative 15 equaling 3x is exactly the same as 3x equaling negative 15. It's just swapped round. That's exactly the same. It's just also a neater way of doing it. So how could we balance this out? Well, why don't we divide by 3 on both sides? So 3x divided by 3 will just get 1x or x. Negative 15 divided by 3 will be negative 5. And that is how we find x. Balancing can be complicated, especially when it's not going the way you want. But I would definitely recommend that you stick with it so the x will always have a positive value. Because then, once you solve it, it'll be easier to divide a number by a positive number than a negative one. I mean, how easy was it to divide it by 3? I'm sure it'd be more difficult to divide it by negative 3. So why don't you just stick with that? Let's move on to another one. Now this is a really good one because we've not done x squareds before. So let's focus on this. We have 2x squared plus 3 is the same as x squared plus 28. Now I want to balance this out. So what I'm going to do is I'm first going to move me x's to the other side. In this case, x squared. So I've got 1x squared here and 2x squared here. I want to make it positive, so I'm just going to minus x squared on both sides. So 2x squared plus 3 minus x squared will just be x squared plus 3. And then x squared plus 28 minus x squared will just be 28. Now, what do we do next? Well, to balance this out, we have to... You tell me. This is your challenge for today. Now, we haven't done x squared yet, so this is your time to shine. I have x squared plus 3 equals 28, and I want you to find for me what x is. But I'm going to tell you this. There is more than one value for x. There's more than one. What is it? I haven't done much on this topic, so let's see how you do. But I want you to solve this problem. What is x and how much more balancing do we need to do? What do we need to do to find x? I'll leave that for you. But I want you to complete this problem for tomorrow. Good luck. Keep our children learning. Have a good day.